Good morning, everyone, and welcome to the April 2024 edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Furman. I'm the Deputy Director of NOAA's Southeast Regional Climate Center, and I'll be giving a climate overview of the past month. Our other speakers today are Todd Hamill from the Southeast River Forecast Center, who will provide a water resources update, Pam Knox from the University of Georgia, who will provide an agricultural impacts update. And joining us today, we have Dr. Walker Ashley from Northern Illinois University, who will be talking about tornado vulnerability in the Southeast. So thank you all again for joining us. Just a reminder to type your questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to the recording in the next day or so. All right, so let's get started with an overview of the climate. So temperatures over the past month were generally above average across the region, especially across the northern tier, where many locations were running about 3 to 4 degrees above average. Temperatures were near average to slightly above average across the southern tier of the region. Looking at Puerto Rico, we see a persistence of above average temperatures, with several places, including San Juan, recording one of their warmest starts to the year on record. Unfortunately, temperature data on the U.S. Virgin Islands have been limited over the past month or so, but the data we do have suggests the above average temperatures have likely persisted there as well. Okay, next slide. So in terms of precipitation, it was more of a mixed bag this past month, with areas of above average precipitation and areas with below average precipitation. Given the wide range in precipitation anomalies and the varying precipitation climatology across the region, I'm showing the percentile values here to better highlight those areas that were anomalously wet, specifically those in the top quarter of their climatological distributions, and anomalously dry are in the bottom quarter of their climatological distributions. And what we see is that southern portions of Georgia, North Florida, South Florida, and eastern portions of the Carolinas and Virginia were rather wet over the past month, with precipitation running between 2 and 6 inches above average for many locations. And some locations were actually exceptionally wet. Tallahassee, Florida recorded over 7 inches of rain in a period of just 9 hours between the 10th and 11th of April. Valdosta, Georgia recorded over 5.5 inches of rain on April 11th, which was the wettest April day on record for that station since 1948. On the other hand, much of the interior of the region, from central Alabama up through southern Virginia, has been relatively dry recently. Eastern portions of the Florida Peninsula have also been dry, especially around Vero Beach, where rainfall totals over the past month have been less than half an inch in most cases. Across Puerto Rico, precipitation has generally been above average, while CoCoRa's observations on the U.S. Virgin Islands suggest mostly above average precipitation there as well. Okay, next slide. So no surprise, these precipitation patterns line up with the current drought monitor. With the exception of a small pocket of moderate drought in western Tennessee, the Southeast is currently drought-free, though areas of abnormal dryness have expanded across eastern North Carolina and emerged across eastern portions of the Florida Peninsula, where precipitation deficits have been the greatest over the past several weeks. Okay, next slide. Looking in the Caribbean, we see reductions in abnormal dryness across Puerto Rico and some contraction of moderate drought on the eastern side of the island, though moderate drought persists in the northwest. In the U.S. Virgin Islands, abnormal dryness persists on St. Thomas, while St. John and St. Croix remain free of any dryness or drought. Okay, next slide. So as we heard last month, weather conditions across the region have been conducive to high levels of airborne pollen. On April 2nd, Atlanta recorded its third highest daily pollen count on record with over 8,700 grains per cubic meter. In Raleigh, pollen counts broke daily records on April 1st and April 3rd. And if we look at the accumulated amount of pollen in Raleigh through the first several months of the season, we see that 2024 now ranks #1 since records began in 1999, and we still have 7 more daily reports to go before the end of this month. Okay, next slide. So over the past month, the coupled ocean atmosphere system over the tropical Pacific continued to reflect a weakening El Niño. Most models indicate a transition to ENSO neutral over the next couple of months, with La Niña potentially developing later this summer. Okay, next slide. And earlier this month, meteorologists at Colorado State University issued their initial forecast for the upcoming Atlantic hurricane season, which officially begins on June 1st. The forecast calls for an above normal season across all forecast parameters, including the number of major hurricanes. Confidence in this forecast is also unusually high for this time of year, owing to the expectation of a transition to La Niña conditions later this summer, as well as warmer than normal tropical Atlantic sea surface temperatures. Okay, next slide. So as we look over the next 3 months, we see that above average temperatures and above average precipitation are favored across most of the region, with equal chances of above and below average precipitation across South Florida. Okay, next slide. And if we look across the Caribbean, we see that above average temperatures and above average precipitation are also expected over the next 3 months. Okay, next slide. Looking at the seasonal drought outlook, we see that drought removal is expected across western Tennessee, while the rest of the region is expected to remain drought-free through the end of July. In the Caribbean, the expectation of above average precipitation that we just saw is reflected in the removal of drought across Puerto Rico, with no new development expected across the region through the first part of the summer. Okay, next slide. So looking ahead to next week, above average temperatures are likely across the region, while precipitation is divided, with above average precipitation across most of the interior of the region, near normal precipitation across the eastern half, and below average precipitation expected across Florida and South Georgia. Okay, next slide. We look out to 2 weeks as we turn the calendar to May. We see a very similar pattern with above average temperatures and mostly near normal precipitation, except to the west where wet conditions are expected, and across South Florida and coastal sections of North Carolina and Virginia, where dry conditions are expected. Okay, next slide. And as we get into mid-May, we see that equal chances are found across the region and a good portion of the country as well, meaning there's no tilt in the odds towards either above or below average temperatures or precipitation. Okay, next slide. Okay, so here's the summary for you all to look over after the webinar. I'm also happy to answer any questions at the end. And with that, I'll turn it over to Todd.
Thank you, Chris. So we can go ahead and go on to our next slide and start talking about the stream flows. It's very interesting, you know, over the next couple of weeks, it's almost a summer pattern that's a touch cooler in the southeast, that we have a bubble of high pressure over us that's keeping the rain from the fronts from really getting in and bringing moisture in the southeast. So a very interesting time of the year, but it's also a transition time of the year, and you can see that for the southeast. One of the things you'll notice in the graphic, especially to the right, shows you know, a full 2 years of stream flows across the southeast. And one of the things that you'll notice is that we're kind of peaking. You know, you see over the whole southeast, you see the whole area is peaking as far as when we see the highest stream flows in the southeast, and we really start to fall off now. So this is our transition time from the competition for water really has begun to increase. I was just driving north over the last couple of this past weekend, and you can see how it's greening up the further you come south, and how we're really, you know, finally starting to see that leaf out. So there's it takes a lot more water to get that water to the streams and see the flooding. And so we're really, for the southeast, we're pretty normal for this time of year. We, you know, we've had some ups and downs all through the southeast, but we've kind of stabilized. And while there is some areas of drier air or drier soils, and there is a little bit of wet, it's kind of a mix. So we'll go ahead and look at specifically at each state. Let's go ahead and go to the next slide. And what you'll notice is that Alabama, once, you know, you'll notice, especially as we were concerned in the fall when we were doing these, that we were concerned about the drought. And the only reason we weren't concerned about the drought was because we were expecting an El Nino winter where we would see heavy rainfall, which should bring us out. And sure enough, that's exactly what happened. And in Alabama, we came out of it very quickly, and we've been pretty wet, but again, it's stabilized, and we've stayed in the normal region. So as if you look at this winter and think we've had a really wet winter, or we really haven't had a really wet winter, but it feels like we've had a pretty good bit of flooding. And so here's Alabama, and it is starting to trend down just a little bit as we see some of the south parts of the state have been central and south parts of the state have been a little bit drier. Georgia has stayed close to the above normal. We've had some decent flooding in the last couple of months, and that has impacted that. So stream flows remain high. Florida's a little bit opposite, and we've talked about this before. They've actually benefited from that dryness in the central part of Georgia over Lake Okeechobee, because they've needed to kind of get rid of some water before we start our wet season, which should be coming up in May as we start to transition there also and start to get sea breeze thunderstorms, more tropical weather, and that's when we expect a lot of rainfall. So there have been some benefits to it being a little bit drier in Florida. So let's go ahead and go to the next one, and this will go on the eastern seaboard. And here's South Carolina. And South Carolina has been very up and down. We've had some very wet times, especially early in January. We slowed down in that February timeframe, but again, March was busy. North Carolina was much the same thing, very similar. And you see the same thing for Virginia, where that early part of the year was very, very wet for some of those areas and took us very high, but we've slowed down a little bit. You can even see that in North Carolina, and we saw this a little bit where there's some dryness along the coast, that it has affected those stream flows, and it started to get into probably below normal in a lot of those areas. But we did see some recent rainfall, and that has improved conditions. So let's go ahead and go to our next slide. And so with all that rainfall that Chris was talking about down in Tallahassee and the Valdosta area, the northern Florida and this area is seeing some significant flooding in there. We've got some in moderate flood stage, and during an El Nino year, we usually see something like this. It ended up being maybe a touch later than we would have expected, but it did come, and so it will take a few weeks for that water to get through those systems and to get through and all the way down to the coast. So that's our most active part of the Southeast right now. And like I said, it probably will stay that way. So let's go ahead and go on to our next slide. And this is the last time I'll show this slide, at least, for a while. I might show it sometime in later in the summer to highlight Florida. But I show January to April as the typical high stream flow period for the Southeast. And that is where we are. We're at the end of April. We're really starting to see things kind of die down a little bit with just heavy rainfall in spots, more spotty. But again, at this time of year, it takes a lot more rainfall to put us into flood. But we did see that kind of rainfall in northern Florida, and so that's why we're where we are. So again, we'll go to the next slide, and it kind of goes to the climatology of where we are. And so we're in week 17, and so we're coming to the end of that time when we expect more flooding, we can see more flooding, and we start to get into more of an in-between time. I say this probably each month, but remember, we can get flooding during any time of year, both moderate and minor floods at any time of year. So we always need to be prepared for it. However, we're coming out of that season where we would be more likely to expect it. And we start to have a little bit more of a quiet period. And this quiet period really does last to the peak of hurricane season, that August 15th to October 15th timeframe, when we really start to see some of that heavy rainfall. But with tropical systems that can move out of the Gulf, and with a potentially active tropical season, this could we could see probably some of that flooding during any time of the year. And especially as we get into June and July, with the warm waters in the Gulf and the Caribbean, things could start to spin up much more quickly. So again, it's something we're going to have to watch. So in my last slide, I apologize. I went ahead and use the Florida group in here. We are at a very low time. We typically don't do. Now this is for the Central and South Florida groups. That North Florida group acts more like the rest of the Southeast. And so we don't include that in this climatology. This is more for Central Florida around the Tampa area and on the east coast of St. John's, and then Lake Okeechobee further south. And so that's why we're not seeing as much flooding from this time. It's usually more, and the Suwannee River Basin and those basins tend to act more like the rest of the Southeast. So we're really getting into our quiet time, but you can see as we get into Central and South Florida that things really start to pick up as we get to the end of May or early June. And that really, for Central Florida, is their flood time of year. So we're still a few weeks away from really starting to see that spin up. So I think this is my last slide where we're still talking about the slightly above normal risk for river flooding. Now, above normal, this is the time of year when we don't expect much flooding, but we've been wet. We have had enough rainfall that if we did see some decent rainfalls during this time, which we kind of do, that we would have that chance for to put something into flood. However, the thing that holds us back is that we are looking to be a little bit more under high pressure. And so it looks like we're finally at the end of our winter El Nino season, and that things are flipping. We'll go to neutral and then to La Nina, and we'll deal with that as we get into summer. And so that is my last slide. And here's the Southeast summary, and you can go ahead and take a peek at that on your own time. And with that, I'll pass it over to Pam.
All right. Well, thank you, Todd. I appreciate all the information. The farmers have certainly felt that rain effect in South Georgia. Let's jump right into the agricultural impacts. Some of the recent conditions that we've seen and some of the impacts on agriculture, the wet and windy conditions that we had in the last few weeks has really been a problem for farmers that are trying to get into the field and plant. You know, when you have really wet soils, it's hard to drive the equipment out into the fields, and the seed just tends to sit there and will sometimes rot. And so some farmers have actually switched from corn, which takes cooler temperatures and longer growing season, to cotton or peanuts, so that they can take advantage of the current climate conditions a little bit better. And so we're seeing some changes. They usually just trade in their corn seed for something else. The recent warmer and drier conditions have allowed the acceleration of spring planting. The cold weather that we had the last couple of days will slow that down just a bit, because as we have that cooler temperatures, any seedlings that are in the ground are more likely to have fungal diseases. Fruit is looking really good this year. There's been a lot of pictures I've seen of really yummy looking strawberries across the region, and blueberries and peaches both skirted by that frost on March 19. And for most of those places, it looks like they're going to have good harvest. In fact, I saw in South Carolina, they're having to thin the peaches so that the ones that they have on the trees will get to a good size. So that's really great news for them. As I said, there have been some problems with wet conditions and fungal diseases. They're harvesting Vidalia onions in Georgia right now. I think they've just released those. And so if you like those sweet onions, you could look for them in the stores, but that has slowed the harvest just a bit because the onions like dry conditions. Pastures are looking much better right now because of all the rain that we've had. A few places are still feeding some hay, but a lot of people have their cattle out on the pastures now, and so that's good. But we have to keep in mind, I tend to focus on Georgia because that's where I am, but parts of Virginia and Tennessee are still preparing for their main planting season because they've been colder. Last night or early this morning, we had freezing temperatures all the way down to Blairsville, Georgia, which is in the Northeast Mountains. And so frost is not over for those parts of the region, as you'll see in a minute. Let's go on to the next slide. The surface hydrology, first of all, soil temperature on the left shows the entire eastern half of the country, for the most part, is warmer than normal this time of year. This is the surface soil temperature. And so that's been really good. Most seeds have a particular temperature that they want. Corn is usually at least 50 or 55 degrees. Cotton and peanuts require soil that's a little bit warmer. And so those are things that the farmers are watching very carefully. Soil moisture on the top, you can see some recent drying in western South Carolina and in northern Georgia and central Alabama. That's really quite shallow soil moisture. If you look deeper, at the deeper levels, there is quite a bit more moisture there from the rain that we've had earlier this winter. So let's go on. Soil temperature shows it's now time to plant. The map on the left there is from the Georgia Weather Network, and you can kind of see that really the entire state is above that 65 degrees, except for that one station way up in the north. That was probably just partly the time of day. There is a map like that with individual sites from North Carolina. There's the website there if you want to go see that. But everything is looking pretty good. Like I said, cooler conditions for the last couple of days have slowed things down just a little bit. But I don't really see that happening for the next week or so. So I expect crop planting and crop growth to really accelerate. If we go on, the frost in the last days has been confined to really North Carolina and Virginia, and a little bit in Georgia where the higher elevations are. So that shows, and I had to turn in these slides before we got this morning's temperature values, but I certainly saw a number of stations in far western North Carolina and in Virginia, and even like I said, down into Georgia just a little bit, where they would have not only frost but even some freezing temperatures below 32. So we're not past frost for that. And if you go on to the next slide, you'll see that right now we're in the light purple region. So the last freeze at 50% is now out of the region. But 1 in 10 years, we can still get frost this late in those areas where it shows the light purple, which is most of western North Carolina, northeastern Georgia, and even a little bit there in Alabama. This map, unfortunately, does not show Tennessee or Virginia, but you can find that in other places. So this will probably be the last time you'll see this map until fall. And let's go on. Here's my summary of the ag impacts and outlooks. You can check these out later. It's looking good. The farmers are really busy, and I think it's going to be a good year. At least I certainly hope so. And now it's my pleasure to introduce our guest speaker today. Walker Ashley is a graduate of UGA, which is great. And he's going to be speaking today about tornado vulnerability and risk in the Southeast. And so he's going to run his own slides and take it away, Walker. Glad to have you here.
Well, thank you. Let me make sure I can get my slide sharing here. Are we good to go? Can you see the slide?
Not yet, Walker.
Okay, hold on. How about now?
Yeah, you're up. Looks
All
good.
right, good deal. Thank you. And thanks for the invitation, Chris and Meredith, to speak with you all today. It's timely. I'm looking out my back window here at my house in DeKalb, Illinois, and the farmers are out there. He's planting either corn or soybeans, so I'll find out probably in about 6 to 8 weeks what we have in the backyard here. But today I'm going to turn the page here, and we're going to talk about tornadoes, and more importantly, talking about the changing risk and vulnerability landscape, particularly across the southeast part of the United States. I got a lot of slides, a lot of material. If I go through too quickly, you can always find my research at my homepage there, and any forthcoming research I'll post there as well. So maybe bookmark that if you're interested in looking into this topic a little bit more detail. So I think we're all pretty familiar, unfortunately, with scenes like this. This comes from 2021, a scene across Kentucky here where we see almost a complete destruction of a neighborhood. I've been fascinated by tornadoes going back to my childhood with both my mother and my father's home communities and houses impacted by tornadoes in Georgia. I grew up loving weather. I'm very fascinated by the weather extremes, and so it was only natural that I found myself into sort of this research pathway where I've tried to examine why we're seeing changes and impacts, particularly across the southeast part of the United States. And when I look at changes, I like to frame them as really looking at sort of two different perspectives. And the first is the changing risk climatology, and that is I look at this from a climatological risk. So what's the probability of a tornado path moving across a particular area? And on the flip side is the vulnerability, which is an extremely complex topic, one that I certainly can't do a full assessment of today, but I'll try to hit some of the big take-home points when we're looking at the loading vulnerability die here. So let's first and foremost take a look at risk. And there's two different ways that we can assess risk. We can look at the past record, which are the observations and reanalyses that I think some of us are familiar with. I consider that sort of the rear view mirror perspective. And then what I'll try to highlight today is looking forward. We'll use a numerical modeling perspective to look at how not only environments, but how the storms themselves may change as we move into the 21st century. I'll highlight sort of two different approaches to this, whether it be the implicit, where we're looking at the environmental ingredients that are supportive of tornadic storms, or the explicit modeling of these events, where we actually can simulate not only the storms, but the perils themselves. So if we look historically at observations and reanalyses, first and foremost, I'll say that if you've ever looked at storm data and looked at it for a long period of time, you have an appreciation for just how difficult it is to pull out trends within those data. So at this point, most of the research suggests there's very limited evidence to date that we're seeing significant increases in tornadoes. If you look at just EF0 and EF1 tornadoes, we've seen a significant increase, but really a lot of that is just simply due to observations and more people documenting them. There is no clear trend in the annual number of tornadoes, and there's few robust trends seen over the most recent decades, especially if you control for just significant tornadoes, which are the ones that we tend to worry the most about. There is research that has revealed from Harold Brooks et al. That suggests that when we do have tornadoes, we have a more clustering. That is, we have more tornadoes on those days when we have a tornado day. I think some of that is just, again, due to a bias in the reporting. But the research is a little unclear as to why we're seeing this clustering. And then some of the research by my colleague, Dr. Victor Gensini, has found not only an environmental shift, but an observed shift in the number of tornadoes more eastward, which is concerning, of course, for our audience today, which is predominantly made up of folks from the southeast part of the United States. And I'll come back to this a little bit later in the discussion. If we try to start linking changes in severe convective storms, those tornadoes, hail, and that produce tornadoes, hail, and damaging winds to climate change, you'll note that of all the different perils that we assess and are concerned about, this is the lowest on the totem pole. We have the least amount of confidence and least amount of understanding of attributing climate change to the changes in their severe convective storm frequency or magnitudes. So let's talk a little bit more about how we're assessing these changes. I think most of us are familiar with how to make a chocolate chip cookie. These are the basic fundamental ingredients we need in order to make a chocolate chip cookie. And just like we deal with baking, we need fundamental ingredients to create a severe convective storm. And we know this as basically we need a low tropospheric moisture, some sort of steep lapse rate in the low to mid levels of the atmosphere to give us a sufficient amount of instability or energy in the atmosphere sufficient for storms. An element of shear, whether it be a change in wind direction or speed with height in the atmosphere, usually takes an ordinary thunderstorm and turns it into a menace. And then something to lift that air up, whether it be from a cold front, a differential heating boundary, a sea breeze or lake breeze. It comes in a variety of different mechanisms. But if we combine all of these ingredients together, we can get a severe storm like we can see here, not across the southeast part of the United States. This is in the Sandhills of Nebraska in this particular case. So what are our findings? And I don't have the time to go through all the implicit modeling efforts that have been out there in the last decade or so, but to briefly summarize this graphic from Diffenbaugh et al., looking at the number of changes in the number of spring severe days across the United States, you'll notice that we're seeing a robust increase across most of the area east of the Continental Divide. And if you look at all the different GCMs from the perturbations that they assessed, we're seeing roughly a 40% increase in the percentage of anomaly severe days for this spring period as we move into the 21st century. So what is driving this? Most of the research concludes that it makes sense. If you think about climate change, we're seeing an increasing heat and moisture into the atmospheric system, which increases the amount of energy for these storms. Interestingly enough, we find some slight decrease in the amount of shear in the environment, but the findings to date suggest that the shear is not decreasing on the days when we actually have energy supportive of thunderstorms. So unfortunately, while we're seeing an increase in at least two of the ingredients and a slight decline in one of the ingredients, that decline is not happening on the days that are supportive of severe storms. The problem with implicit modeling is largely derived from global climate models, which have a grid spacing of anywhere from 100 to 250 kilometers, although improving over the years. But this clearly is not at the scale to resolve an individual thunderstorm like you're seeing on the right here that actually generates the perils. And thus we need to necessarily move into an explicit modeling framework. And that is, to keep it short, we're going to use a weather model to simulate changes at the climate scale. To resolve these storms, we have to increase our grid spacing and our temporal output. For instance, on the left, you might be, again, 100 to 250 kilometer grid spacing, and you're seeing some of the precipitation output on it from a global climate model. And on the right is a regional climate model where we might be explicitly resolving at, say, 3.75 or 4 kilometers at maybe 15-minute increments. And so you can see the difference between sort of the climate modeling framework and the weather modeling framework on the right. The beauty of the framework on the right is it allows us, again, to explicitly resolve these storms that generate the perils and create sort of populations of these events when we start to stack them over the years. This is, as you'll see, very, very valuable. The issue, of course, is that it's extremely computationally expensive. And even once you're done with the computations, trying to figure out where to store the data and process the data are also very big hamstrings. And so what we find is it took us about, and I'll show you some of the results here, about 2 to 3 years to generate the simulations. And then where we've stored this, we've been punting it from in-car computers to DOE computers. We've had a struggle of trying to find a place to store these data. And right now we have about 700 terabytes just for these simulations alone. So to show you how we do this, we've largely used the resources of National Science Foundation and NCAR, primarily Cheyenne, although we hope to move on to the derecho system here shortly. We've also used the San Diego Supercomputing Center's resources, although that computer there is being decommissioned here shortly. And of course, the DOE has a lot of computing resources and storage facilities that we've employed, and just again, takes many months, if not years, to process these data to get some of the results that I'm going to highlight here. So our particular RCM output is generated from a GCM that we force onto the weather and research model, the WRF. We have a grid spacing of about 3.75 at 15-minute interval. And we have a historical period from 1990 to 2005 that we're comparing against. And I'm largely just going to show you the end of century results here. So that would be from 2085 to 2100, although we do have just in the last year or so some mid-century results that we're starting to assess. We looked at 2 different sort of warming scenarios. We looked at RCP 4.5, which is a more middle of the road, intermediate, one that will probably angle towards in the mid part of this century. And then finally, the real pessimistic warming scenario, which is 8.5, which we hope we will not go to. And over on the right, I'm showing you sort of the resolution of where we're looking at instability or CAPE in the environment just east of a dry line supporting the development of supercells across the I-35 corridor here. Just a real quick assessment of some of what we've done here. I don't have time to go through all the different sort of perils and hazards we've looked at, but here it's just looking at just changes in reflectivity. So simulated reflectivity of 60 dBz and greater. Most people in the operational meteorology community would probably start getting concerned when we start seeing reflectivity of 50 or 60 dBz. What you notice is across the domain, we're seeing significant increases in these sort of high-end events across most of the east of the Mississippi and along and east of the Mississippi River, whether it be intermediate warming or the pessimistic warming scenario. If we actually go in and take a look at the storm that produces most of the significant tornado and hail that we deal with, and that is known as the supercell, which I'm showing you sort of a graphical visual here of time lapse on the right. These are characterized by their rotating updrafts, and these are the particular type of storm that we're most concerned about. So if we think about the super outbreaks, whether it be April 27th, you know, pick your favorite day that's produced a significant tornado impact across the southeast part of the United States. More than likely, it was induced by a supercell or a supercell embedded within a quasi-linear convective system. So if we look at the counts where we summed up the number of supercells across our domain, whether we're looking at just counts, the number of supercell hours, the cumulative area affected by supercells, or the most intense part of supercells, as we move in the future, all of these across the board are positive. So we're seeing notable, and in many cases, significant increases in the supercell hazards as we move into the 21st century. Spatially, we notice that we're going to expect anywhere from 1 to 3 more supercells in a given year along and east of the I-35 corridor, with slight declines across the Great Plains of the United States. And that's not to say that Tornado Alley, as we colloquially know, is going to disappear. There's just going to be a declining number of supercells and hail and tornado events across the Great Plains, with an increase across the Arklatex, Mid-South, and Deep South. And I can get into sort of the reasoning behind this down the road, but I invite you to take a look at our paper in BAMS where we discussed this just last year. So overall, we see an increase in the frequency of severe environments and storms resulting, particular perils from these storm events. The research suggests we'll see an earlier season, so a more active February and March than what we've been used to. But also, and interestingly enough, one of the results was that we'll see a severe weather season that might wane a little earlier. So it might conclude by June rather than say July or August like we're seeing now. One of the hallmarks of climate change on our peril landscape will be the increased variability, which is going to drive our insurers crazy. But that variability is perhaps the biggest fingerprint of climate change on the peril record. We'll see a notable increase in intense storms and broadly, as I've suggested, a general eastward shift in the severe storm climatology, with a decrease in the plains and broadly an increase across the Mid-South and Arklatex. But when we look at tornado disasters like we're seeing here in my home state here of Illinois, on Washington, Illinois community, I see obviously a changing risk landscape. To what extent we don't quite know yet, but I also see a changing vulnerability landscape. And this is the elephant in the room when we talk about impacts, whether it be tornado impacts, hurricane impacts, really any sort of hazardous situation, vulnerability is the driver. So first and foremost, when we look at vulnerability, the primary constituent of that is just simply exposure. The number of people and their assets in the way of these severe convective storms. And here I'm projecting the land use from 1940 all the way through 2100 for a specific scenario. What you'll notice is that the land use has broadly increased across, and I don't think I have to convince any of this, but it is projected to continue to increase as we move through the 21st century as well. And give you some broad statistics and breakdown on the left side there, illustrating some of the changes in exposure that we've seen, and ultimately the main primary driver in the increasing impacts that we've seen over the last 2 to 3 decades. We've called this the expanding bullseye effect, and I hate to use this sort of terminology of thinking of humans and our possessions as targets, but we really are targets to these perils. I give you a theoretical and then a kind of a real world example of Wichita, Kansas, of this expanding bullseye effect. And it just becomes a lot easier for a tornado that might strike randomly across the landscape, that over the time that bullseye of land use development increases, the chances and odds of something being impacted go up significantly. And this is no more so true than in the Mid-South. And in fact, if you look at all the regional depictions here from a paper that Stephen Strader and I did back in BAMS in 2016, the Mid-South is the one that really takes the cake here. You've seen roughly a 10-fold increase since 1950 in the disaster potential for tornadoes across the Mid-South. That's far more than again, colloquially what we know as Tornado Alley, whether it be the high plains or central plains, or even my backyard here in the Midwest. And so this is one reason why we've seen, if you think back in your memory over the last decade or two, the significant impacts in tornadoes across the Mid-South seem to have been increasing. It's largely just due to a juxtaposition of, as I'll illustrate, increasing risk, but most importantly, increasing exposure across the region. If we just run some Monte Carlo, so we can run thousands of tornadoes across a landscape and come up with some of these, what we call probability of exceedance curves, by just simply changing the land use, what you'll notice is the number of annual housing units impacted has grown significantly since 1950, and is projected to grow significantly more as we move into the 21st century. So whereas in 1950, just the thought of a 10,000 housing unit impacted event was almost negligible, if not zero. As we move to 2100, in any given year, we might see a 20% probability of such an event occurring across the Mid-South, which is really unfathomable for our emergency managers and really forecasters to even think about. The odds of that is quite significant. So what about that spatial shift in tornado risk that I talked about? This is some work that Stephen Strader, myself, Victor Gensini, and Stephen's grad student have worked on, where hopefully will be out in publication here shortly. But the what we've noticed is an increase in the tornado risk across the Mid-South, which I'm highlighting here in sort of the darker red, and a decrease across the southern Great Plains, particularly primarily southern Great Plains of Texas and Oklahoma. But exposure isn't constant either, right? We've seen largely increases in population density throughout really the rest of the world, but also certainly east of the Continental Divide here in the United States, with just a few counties, very rural counties, where we've seen a population density decline over the last few decades. But when we commingle these together, we kind of get this graphic in the center here, where we see in the red here an increase in population with an increase in tornado days, and in the blue a decrease in population and a decrease in tornado days. And so what we've done here on the right is, again, we've simulated using Monte Carlo thousands of years of tornadoes events across these two domains. And on the graphic in the top right, I'm representing the Mid-South, and then the graphic on the bottom right, I'm representing the results for the Southern Plains. And there's a lot to take in here, and I invite your eyes to kind of peruse these, but we're seeing overall increases in impacts over this 3 to 4 decade period, but for various reasons. In the Mid-South, we've seen obviously an increasing risk, but most importantly, an increasing exposure. And you can see that probability of exceedance curve is really stretched out such that the odds of impacts have significantly increased over that period of record. Whereas in the Southern Plains, we've seen increases, but not at the same sort of level as what we've seen in the Mid-South. And in fact, we've seen a decline in the tornado risk across the Southern Plains, but because of the rapid increase in exposure, unfortunately, we've seen still an increase in the potential impacts across this region. Both of these graphics reveal just really the importance of exposure in driving the changing impact landscape that we're seeing. While I know that a lot of the oxygen in the room is taken by the changing risk landscape, if we really want to point our finger at what has been driving the changes and impacts, and more importantly, what's going to continue to drive these as we move into the 21st century, you need to point your finger at land use change. But land use and population and housing unit is only one component of vulnerability. And now there is a lot on this graphic. In fact, I probably spend an entire day talking about this graphic in my Science of Disasters course. And so this is one you can kind of sit back and kind of ruminate on here a little bit. But we typically in the physical science world focus in on the right. We look at a specific hazard and we just think, oh, that's what's causing this particular impact. Really, many of the social processes and structures of what we call social context have been there for decades, if not centuries. And these vulnerabilities are what are driving the impacts. And as I state here, disasters occur because people are vulnerable. That is, for physical, economic, and or social reasons, they are exposed and will suffer and have less resilience, by the way, when an event occurs. And so the deepest causal factors may often be quite removed from the disaster event itself. And this is why I hate that term natural disaster. There is no such thing as a natural disaster. There are natural hazards, but there is very much so no such thing as a natural disaster. So when we look at the climatology of tornado risk, you see that, again, the Great Plains show up there. But when we look at mortality, the mortality rates in the Mid-South are 4 to 5 times greater than those of what we see in other parts of the United States. Now, I caution that graphic at the top is a little bit, factually, it is correct. That is, the frequency of tornadoes is greatest in the Great Plains compared to anywhere in the world. But if you actually look at tornado paths, the #1 tornado risk landscape in the world is the Mid-South. And that is because tornadoes have a significant path length and width in the Mid-South compared to anywhere else. And for that reason, the risk is actually highest in this region, in our region, the southeast part of the United States, of anywhere in the world. But it's very hard for people to get out of their mind that tornadoes simply occur in the Great Plains of the United States, which is nothing further from the truth. But I give you a number of reasons, whether it be the risk landscape or the vulnerability landscape, that sort of overlap in the Mid-South that leads to the culmination of some of these disasters. I'll focus on a couple of those real quick. First and foremost, one of the primary problems that we have in the Mid-South is our weak, or what I consider substandard housing, and particularly mobile and manufactured housing. This leads to about 50%, if not a growing percentage, of our tornado mortality is people that are unfortunately succumbing to these events in these particular structures. I'll give you some basic statistics here about how easy it is to destroy these in even a relatively weak tornado. But what you'll notice is that ultimately different societal groups will maybe share the same exposure to the hazard, but have diverging capacities and abilities to deal with that hazard when it does occur across the landscape. And we've examined this from an Alabama and Kansas perspective. What you'll notice is that the mobile homes in Alabama are more than 4 times as likely to be hit compared to those in Kansas. And that's attributable to just simply a greater number of mobile homes. But more importantly, mobile homes in the South are spread across the landscape. Those of you that live in the South know this. That's quite a bit of a different sort of finding than what we find in the Kansas area, where most of them are in communities. And so that changes the sort of impact landscape. Another factor is our nocturnal vulnerability. We've done some research going all the way back to 2008 and more recently in 2022, highlighting this particular problem. And what I'll note here is when we simulate these or look at the changes in mortality, we've seen that of all the different periods where we may see, say, a decline or maybe no trend at all, it's really that overnight period, really from midnight through sunrise, where we've seen a quadrupling of the impacts and mortality. So if we want to focus in on a couple of things, I would focus in on mobile home manufactured housing, and particularly tying down those structures or anchoring them correctly, and somehow getting the word out better during this overnight period. Here's a sort of simulations we've done, just showing you broadly the differences across 3 regions for the daytime events, the impact probabilities versus nocturnal. And overall, the 90th percentile, which are the events that we tend to concern ourselves about across the Southeast, are more than 2 times greater than the other regions out there. So this is certainly one of the primary concerns that we have, is if you're a forecaster in the South, these sort of nocturnal events are very, very difficult nut to crack. So while climate change may modify severe storm seasonality, frequency, magnitude, disasters are social constructs, and it really is that overlapping risk with vulnerability, and most importantly exposure, that is commingling to create the impacts, not only in tornadoes, but when we look at hail, derechos, basically any hazard that you can think of. It really is the overlapping risk and vulnerability landscape that's creating the sort of changes that we're finding unfortunately on an annual basis these days. So, the natural question is what are the solutions? And there are no easy solutions to these disaster problems. These are long stated, as I mentioned in the vulnerability slide, these are long stated root causes that are sitting out there, whether it be poverty, land use. These things take decades, if not centuries, to find solutions to. If there were things that I could point, if I could be a policymaker and somehow could stay elected for longer than 2 years, what would be the 2 things that I would focus in on? It would be the adoption, improvement, and enforcement of regional land use policy, and really the updating and improvement and enforcement of building codes. Unfortunately, these things really are at the local level. There really is no federal legislation that sort of from the top down that pushes this on communities. It really is community driven. And that means that there's a tapestry of vulnerabilities across the landscape that is very hard to sort of tie down and improve. You need people of stature and leadership in these communities to push better, push better land use policy, better building codes. And unfortunately, at the end of the day, money talks, and these sorts of things have very, very long time horizons. And so it unfortunately, it might not come to pass, but I hopefully will leave you with this thought that it really isn't a scientific problem. That is that our forecasting ability is amazing these days. Granted, there's some things that we can do. Reduce the false alarm rate would be one of those, but the real challenge here is social and political. If we really want to remedy the disaster problem, whether it be tornadoes, hurricanes, or whatever, we need to think long term, and that's a very, very difficult thing to get over in an environment where we're reelected on a 2, 4, 6 years scale. So I'll leave you with a couple of quotes, one from a forecaster at the Storm Prediction Center and another out there with a more philosophical perspective. And I'll be happy to take any questions that we may have at this point. Thank you.
Walker, that was fantastic. Thank you so much. Hello, everyone. My name is Meredith Muth, and I work for the NOAA National Integrated Drought Information System program, and we co-organize this webinar series with the National Weather Service and with the Southeast Regional Climate Center. And I am trying to show my slide right now. And as we go through, if you have any questions for any of our speakers today, please go ahead and enter those into the question box. I also wanted to just highlight that we have a couple of really excellent webinars coming up in the series. Our next one will focus on the U.S. Caribbean in May, and we also have our annual Atlantic Hurricane Outlook that will be on June 25th, followed by a look at climate and impacts on engineering, infrastructure, and design application in the Southeast. Just a reminder, we will send out a recording and a summary of today's webinar via email. It'll also be posted on drought.com. Please go drought.gov. Please feel free to share. I will go ahead now and direct some questions that we've received to our presenters. The first one is more general. It's actually looking ahead towards the tropical development and the Atlantic hurricane season. So maybe I'll direct this one over to any speaker that would like to speak up. Do you have any updates or thoughts on Saharan dust that may reduce tropical development this summer? I'm curious about how this might reduce the impact caused by high sea surface temperatures. Again, reminding you that we will have a webinar on this on June, but would any of our speakers like to respond? Okay, it sounds like the person who asked this question, Debbie, go ahead and join us on June. We're going to have some experts on tropical development, and they'll be happy to answer those questions for you. Believe it or not, we don't have very many questions. All we have is a ton of excellent presentations. Excellent, excellent. Thank you. We do have a comment for Walker, and I'll go ahead and I'll read this out right now. Would there be changes in the vulnerability assessment with the construction of tiny homes and more barndominium, oh, I've never heard that before, style homes, especially when the interest rates and housing cost rose? So this is a little bit of a stretch, but I guess this is more about construction of manufactured home versus tiny homes, etc.
Yeah, I mean, as far as I know, there is no census or assessment of these tiny homes, and whether that remains a fad or not, I think it'll be a fad. I can't imagine living in a tiny home. I have a little camper trailer, and it's nice for a weekend or maybe a week, but beyond that, I become a little bit I don't know, claustrophobic. But you bring up a good point in that we really have no way to assess where these homes are and distributed across the landscape. But I would caution that these are as vulnerable, if not more vulnerable, than mobile and manufactured housing. In fact, by definition, most of them probably are not tied down or anchored. And that's one of the primary problems we see with mobile and manufactured housing, is that they are not anchored correctly. They are not up to code. And so there's so many moving parts in the installation of a mobile and manufactured house that unfortunately that part kind of falls by the wayside. And it's the most important part to making that structure less vulnerable in extreme winds. But yeah, the viewer brings up a good point in that we just really have no assessment of tiny homes. But I would not be caught in one during a tornado event.
I hear you. I think that one of the reasons why we're not getting many questions is because you are absolutely so thorough, Walker, as well as all of our other speakers. And so again, getting lots of compliments. I'll share a few of these with you offline. With that, I just want to again thank Chris, Pam, and Todd, our regular speakers, and our guest speaker today, Walker. I hope you all will join us next month. When you close out this webinar, a quick survey with just a couple of questions comes up. If there are topics you want to hear about on this webinar series, please let us know and we will work to make that happen. And so with that, I'd like to wish everybody a wonderful day. Stay safe, and thank you for joining us.